Okay, good morning guys. Today's target is polynomial curve sketching. So here's our first example. F of x equals x plus 4 times x minus 1 times x minus 5. The nice thing about this is it's in factored form. Sometimes they're not in fully factored form. Sometimes you have a degree 5 polynomial and you don't even know how to factor that. So we'll have to teach you some other methods. But this one is factored for us, so it's very easy to find the zeros. This one is x equals negative 4. This one is x equals 1, and this one is x equals 5. So that's 3 zeros I just found because it was already in factored form. And this is a degree 3 polynomial. X times x is x squared times x is x cubed. So I know I could have at most 3 real roots. I could also have 1 real root and 2 imaginary roots. Just remember, your imaginary roots have to be even, okay, because of the complex conjugate theorem. So let's go ahead and sketch this. So here's a quick sketch without a calculator. You would not be allowed to use a calculator on this. So the first thing I'm gonna do is I'm gonna graph my zeros. My first zero is negative 4, negative 1, negative 2, negative 3, negative 4. My next zero is crossing at 1. And my next one is crossing at 5. 2, 3, 4, 5. So I just graph my 3 zeros. That's the first thing that you wanna do. Okay, then what you want to do is, if there's a double root, I put a little tiny dr, real soft dr, so I know it's a double root, and your graph will not cross at double roots. It will be tangent at double roots, okay? So the next thing I have to do is decide, is my graph coming up from negative, or is it coming down from positive infinity? It's either coming up from negative infinity, or it's coming down from positive infinity. And the way I do that is I just test a test point from negative infinity to this point, negative 4. It has to be between there, okay? All of these points from negative infinity to negative 4 are all going to be either positive or they're all going to be negative. So I'm going to choose negative 5. You cannot choose this one because that's going to spit out a 0. So, cat, stop eating the garbage! So, excuse me. So, negative 5 is a good test point to use, okay? So I'm going to use negative 5, which lies in between negative infinity and negative 4. So let's punch in negative 5 right here. Negative 5 plus 4 is negative. Negative 5 minus 1 is negative, and negative 5 minus 5 is negative 10, so that's negative. So if you have an odd amount of negatives, that means it's going to be negative. That means all these values between negative infinity and negative 4 are going to start off negative. So that's pretty much all I really need to get a curve sketch. I know it's going to be crossing here, then it's going to cross here, then it's going to cross here. Now I know what you're thinking, Mr. Terry, how do you know how low to go here and how high to go here? Well, I just did a curve sketch, but if you wanted to be really accurate, you could punch in 3 wherever you see an X and see exactly where that point is going to be. And you can punch in like a negative 2 and see how high it's going to go. But like I said, these are just curve sketches. We're just sketching the curve of the graph right there. Okay? So let's do another one. Dropping my sheet here. Okay. Next one, example 2, is f of x is equal to x plus 6 squared times x plus 2 squared times x minus 4. Hey, cats, come on, get out of the garbage. God bless America. All right, anyway, first thing that we're going to do is find our zeros, okay? If they're imaginary zeros, you don't need to find them because you can't graph imaginary zeros. So this one is x equals negative 6. And it's a double root because it's squared. So I'm going to label that as a dr. Negative 6 makes that 0, but it's a double root. This one is x equals negative 2. It's also a double root because it's squared. There's 2 of those x plus 2's. And then this one is x equals positive 4. Okay? This is degree 2, this is degree 2, this is degree 1. There should be 5 roots. So there's 2, 4, and 5, okay? So just like our lesson yesterday, we know we had 5 roots. So let's go and plot them. Negative 1, negative 2, negative 3, negative 4, negative 5, negative 6. I put a dot and I label it dr, double root. That means it's tangent at that point. This one at negative 2 is also a double root, so it's tangent at that point. And then we have 1, 2, 3, 4. It's not tangent. That means it's going to be crossing at that point. It's not going to cross here. It's not going to cross there. It's going to cross there. Now we have to decide, are we coming up from negative infinity or are we going down from positive infinity? And to do that, we just pick a test point. So I'm going to pick the test point that's right to the left of this negative 6. I'm going to use negative 7. So there's negative 7. So that's my test point to see if it's positive or negative. That's all I care about. I don't care what the number is. I just care about is it positive or negative. So let's punch in a negative 7. Negative 7 plus 6 is negative, but when you square it, that's going to be positive. Negative 7 plus 2 is negative, but when you square it, that's going to be positive. And then negative 7 minus 4 is going to be negative. So a positive times a positive is positive times a negative is negative. So that means we're starting off here and we're going to come up and touch our double root, but we're not crossing. So that means we're going to come back down, we're going to come up, not cross at our double root, we're going to come back down, and then we're going to shoot off to positive infinity. So that's a quick sketch of your graph. Now, like I said, you don't know how low you're going to go. Would I mark this wrong if you went only down to there? No, I would not mark that wrong. If you went way down here, I would not mark that wrong. But if you want to get a better approximation, you can just test that point, plug it in, and see where it spits out, and you get a more accurate graph. Okay, but you cannot cross at those two double roots. Okay, let's try another one. Okay, that example had double roots. Let's do one with imaginary numbers, okay? So, look at this one. F of x is equal to x minus 3 times x squared minus 5x minus 6, and then x squared minus x plus 4. Hopefully you can see that. I might have to move my camera a little bit. All right, there you go. Okay, this is degree 1, this is degree 2, so that would be cubic. And then degree 3 times degree 2 would be degree 5. So we need 5 roots, okay? This one's easy. It's x equals positive 3. X equals positive 3 is that root. This one is a quadratic, so hopefully it's factorable. Let's try and factor it. Let's do x minus 6 times x plus 1. The nice thing about this section is all the factoring is pretty easy. So this solution is x equals 6, and this solution is x equals negative 1. This guy is not factorable. Nothing multiplies to be 4 and gives you a negative 1. So I'm going to try to find the discriminant and see if what the nature of my roots. B squared would be 1 minus 4 times a times c. Well, that would be a negative discriminant, which means those are imaginary roots. So these are not graphable. You cannot graph those two complex roots. So let's go ahead and see our curve sketch. So the first thing I'm going to do is plot the zeros, my real zeros. My real zeros are negative 1, 3, 1, 2, 3, and then 6, 4, 5, 6. And then those two complex roots are not graphable. You can't graph them on an XY plane. The next step, let's decide if we're coming up or coming down. So I'm going to test a point to the left from negative infinity to this test point, which was negative 1. So the best one to use is negative 2. So let's go ahead and punch in negative 2. Negative 2 minus 3 is going to be negative. If I punch in a negative 2 here, I get a negative. Let's get rid of that 5 so you have space. Then negative 2 plus 1 is also going to be negative. Then if I punch a negative 2 here, this is going to be 4, and then plus 2, and then plus 4, so that's going to be positive, right? So I have an odd amount of negatives. I have 3 negatives, so my answer is going to be negative. So that means I'm starting off down. Okay, I'm starting from negative infinity. Am I going to cross here or am I going to touch? You're going to cross because that's not a double root. Then I'm going to come back down and cross because that's not a double root. And then I'm going to have to come back up because that is not a double root. It's going to cross. So there's a curved sketch of my graph with two imaginary numbers. All right, let's do an even harder one. Let's do one more, and I'll tell you what, I probably won't, well, maybe I will. We'll see. Maybe I'll just give you quizzes tomorrow and no video tomorrow. How about that? Is that a deal? We'll probably do that. We'll do a real hard one. If you can handle this one, you can handle any of them. And then we'll probably just, I might give you a 10-point assignment tomorrow. I'm thinking about giving you a 10-point assignment assessment grade, because a lot of people have stopped doing this. Don't stop. There's not that much left. F of x is equal to x squared plus 2x minus 8 times x squared plus 4x times x squared minus x plus 1. I gotta check and see if you guys can see that on the screen here in a second. Yeah, you can see it, good. Okay, degree 2, degree 2, degree 2. That means this is degree 6. We should have 6 roots total. Let's see if this guy is factorable. Let's try to factor it as x plus 4 times x minus 2. 4x minus 2x gives me the 2x. Yeah, it's factorable. What's the GCF that you can pull out of here? You can pull out an x, and you're left with an x plus 4. Then this guy right here, I don't believe is factorable. Does anything multiply to be a 1 and multiply to be, or add to be negative 1? No. So my discriminant is 1 minus 4ac. That's going to be negative. So these guys are two complex roots. Two complex roots. So let's make a curve sketch here. Draw a little xy Cartesian plane. And this guy is negative 4. This guy is also negative 4. So that's a double root. So negative 1, negative 2, negative 3, negative 4 is called a double root. So I put a little tiny dr because I know it cannot cross a double root. This one right here is 2. So I'm going to put a dot at 2 and it's crossing. This x is 0. What makes x 0? 0 makes x 0. And then we already got that negative 4, and the other two roots are complex. So let's do the hard part here. Let's test and see if we're starting up at positive infinity and coming down, or starting low and coming up. So I'm going to pick a test point. I'm going to rewrite this down here too so you can see it too. Test point of negative 1, negative 2, negative 3, negative 5. We're going to test negative 5. That's this point right here. That means all these points will be either positive or negative. So if I punch in a negative 5 here, I get a negative. If I punch in a negative 5 here, I get a negative. If I punch in a negative 5 there, I get a negative. If I punch in a negative 5 here, I get a negative. Negative 5 squared is 25, and then negative negative 5 is positive 5, and then plus 1, that's going to be positive, okay? So I have a negative, a negative, a negative, a negative, and a positive. That's 4 negatives, which is even. So that means it's going to be positive. So I'm starting up here at positive infinity. Am I going to cross, or am I going to be tangent at that double root? You're going to be tangent. So then you're going to come back up. You're not crossing. Then you're going to have to cross here, and then you're going to have to cross here and shoot up to positive infinity. So like I said, if you would have graphed it like this, would I have counted that wrong? No. If you would have went up like this and came down, would I have counted that wrong? No. But you better be tangent there, you better be crossing there, and you better start off coming down and shoot off to infinity at the end. Okay? All right, this is one you're definitely going to want to rewind and try to do it by yourself, okay? But you got to get those zeros. If this was not in partially factored form, it would be virtually impossible for you guys to do it. You guys couldn't factor a degree 6 polynomial, okay? All right, I'll tell you what. Once again, no quizzes today. But tomorrow, you're going to have a quizzes assignment that's going to be counted in the assessment category. So you can only take it one time, and you won't be able to get the answers at the end, okay? All right, good job. This is kind of confusing, so watch it over and over again. All right, see you tomorrow.